Hadoop 2.x architecture. Okay. Now in Hadoop 2, you have almost similar stuff. You have name node. Okay. So this is your name node. This is your secondary name node. Of course, there can be multiple name nodes. I'm not just writing them out. Now, this is no more a job tracker. Let me just write JT. We will erase this. And then we have 1, 2, 3, 4, 5. Okay. And here you have data node. Here you have data node. Here you have data node. Here you have data node and data node. Okay. Now earlier you used to have job tracker and task tracker here, right? But now see, this is a node, right? So now you don't have a task tracker. You have node manager. You have a node manager. Every node has a manager, node manager, a process. Okay. Now you don't have a job tracker here, so you have something called resource manager here. Okay. So instead of job tracker, you have resource manager in this case, right? Now here, in case of your task tracker, you have a node manager in this case. Now let's understand how the jobs are getting executed. The way when you store the data into a file, that process will remain same. It goes to the name node. The name node gives you the information about the data nodes across the cluster, and then the put command initiates the request to write the data. Right. That's how it works in Hadoop 1, and that's how it will work in Hadoop 2 as well as in Hadoop 3. Now, let us understand how the job is basically getting submitted. What are those containers, right? The MapReduce slots were replaced by containers now. Okay. Now, this resource manager is divided into two parts. Okay. This resource manager is divided into two parts: scheduler, okay, scheduler and application manager. So if I say this resource manager is basically a process, then this is divided into two parts: scheduler and application manager. Okay. So what happens is a user wants to submit a job. So this is your Hadoop cluster. This is a Hadoop cluster. And now you want to submit a job. So what you'll do, you'll write Hadoop jar command. Right? Don't worry about the complete syntax. We will learn them later. Hadoop jar word count dot jar and some other parameters. We'll study that later. Okay. So the user submitted a job called word count dot jar, right? And this word count dot jar would be submitted to your this job would be submitted to your resource manager. Okay. Now in resource manager you have two things: scheduler and application manager. Scheduler, the responsibility of the scheduler is to schedule the job. The responsibility of your scheduler is to schedule the job, and it just tries its best to schedule the job at a proper nodes, because there are so many nodes, right? Let's say there are more nodes here. There are more nodes here, and you want to run this word count.jar in a file which had 4 blocks. Okay, so B, let's say B0, B1, B2, B3, 4 blocks. And now they will also be replicated, is not it? They will also be replicated. So the replication will happen everywhere, right? So let's say this whole cluster is hosting one or other block of this data after the replication is done, right? So the scheduler job is to schedule where exactly what are the places where the job can be run. This is what would be decided by the scheduler part of your resource manager. Okay. Now, this will never track the progress of a job. Its duty is to schedule the job in the cluster and it's done. Okay. Once it is scheduled, then it will be taken care by your application manager. Okay, then it will be taken care by your application manager. So what does this application manager do? Whenever there is a requirement to run this job now, right, this application manager will talk to this node manager. Okay, and of course this node manager, see, as the name suggests, node manager says it is going to manage this entire node, right? So in this node many job will run. In a single node many job will run, right? So you will not be the only guy running this job. So whatever job you run in this box, in this node, whatever CPU you are using, whatever memory you are using in this node, all these things would be reported by this name node to your resource manager. Okay, to your resource manager, more specifically to your application manager, right? Because as I said, resource manager is nothing but combination of scheduler plus application manager. So this application manager will get a clue of the whole status of a single node, because you have something called node manager that keeps on giving the details to the node manager. Okay, now this application manager, what it does, whenever you schedule a job, whenever you want to schedule a job, this application manager will negotiate and gets one application master. Okay, don't get confused between application manager and application master. See, application master, like every application, every job will have one application master. Okay, so this is basically an application master. So let me write it in full: application master. Application master, right? So this is basically your application master, which would be launched by your application manager, right? Okay, and then this application master can start containers anywhere, here, 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 everywhere, wherever it feels it should run the job. Okay, so see, you have submitted a job saying that, hey, word count is a job which I want to run, and this job would be given to your application manager. The application manager will create an instance called application master. For every application there will be exactly one application master. Now when you say I want to run a word count job on a file which has 4 blocks, then the blocks are present here, 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 and here, right? The blocks are present here, 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 and here. So all this, in all these 4 machines, the job needs to be executed, right? And the job runs on container, right? So this application master will negotiate the containers. So you get a container here, 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 in all different machines, but all of them are reporting to the single application master, right? So there will be only one application master for a job, and that is where you start running your program. So you run your program here, run your program here, run your program here, run your program here, right? So your container is the basic, is the place where your real job execution happens. Now based on the requirement, it could be a map, it could be a reduce, it could be a spark job, it could be anything, right? So those job would be processed, and as the job is progressing, this application master will update this information to your application manager that my job is progressing, and this is the progress of my job. I've completed 10%, 20%, 30%, whatever it is. This is how your Hadoop works all together. Okay, this is how your Hadoop works all together. So you have name node, secondary name node, resource manager. Resource manager is divided into 2 parts: scheduler and application manager. Application manager is a part of your resource manager. Application manager is your part of your resource manager. Don't get confused with application master. You will get confused, I know. So that's the reason I'm putting a lot of focus on this point. Don't get confused with the application master. This application master would be many. See, application manager would be only one across the whole cluster. Okay, your application master would be only one for a job. If I have 200 jobs, then I have different application master for them, right? Whereas my application manager would be just one for the entire cluster, right? So this is one for entire cluster, this is one for one job, right? One for one job, two for two jobs, three for three jobs, four for four jobs, and so on, right? And that's how the whole data would be processed in your Hadoop 2.x architecture. Okay, so that's the beauty of your Hadoop 2. Just a minute, guys.